Once again, welcome to the LJ Institute of Engineering and Technology. Let's start with the our subject mathematics 2 and chapter. We know that first order ODE. Today's topic is formation of differential equation. So in this lecture, we'll learn how to form, how to make, how to obtain the differential equation from given equation. Okay, so ODE, ordinary differential equation, are formed by eliminating arbitrary constant. This is simple concept. That means if we have y is equal to c1 e raised to x plus c2 e raised to minus x, this is our simple equation, okay, and which contain here two arbitrary constant. So by differentiating this y with respect to this variable x two time, exactly two time, not more than two, not less than two, completely exactly two time differentiate, and we will remove this arbitrary constant. As we told that eliminating arbitrary constant, we will get our new differential equation ODE of second order. Okay, so to eliminate two arbitrary constant, as I told, differentiate twice, and which gives us the second order ordinary differential equation. Okay, so in general, if we have n arbitrary constant, so differentiate nth time and we will get nth order differential equation. Okay, so to understand this formation of differential equation better, let's start with the example. This is the part, this topic already you learn in your 12th standard. Okay, so just you have to once you have to observe and then just calculate the extra examples. Okay, so form the differential equation of the equation y is equal to this. Here you can see that this equation contains two arbitrary constant a and b, so you have to remove or you have to eliminate these two arbitrary constant a and b by differentiating this of equation y with respect to x only two time, not more than two, not less than two. Okay, so we will differentiate this y with respect to x twice. So first we will differentiate this y, so we have y dash, or we can say that dy by dx. Now to differentiate this equation, we have e raised to x and this term is in multiplication, so we will differentiate this by using product rule. So first e raised to x as it is, and differentiation of this term is here, plus this bracket, second bracket as it is, and differentiation of e raised to x is e raised to x. Now before differentiate second time, first observe this equation. You can find some relation between equation 1. So you can find this term is exactly same as equation number 1, so we can put, instead of this we can put y, so this y dash become y dash is equal to this as it is, and this is our y. Okay, and you can observe that this is not the equation 1, okay, because we have this minus. If we can take minus outside, if we will take minus outside, so this term become minus, but we have this both are plus. Okay, now after replacing this value, okay, so whenever we'll differentiate once, 99% you will get equation 1 in this derivative. Okay, okay, now again by putting this value y, we have to differentiate this term second time on, and this is the final differentiation because we have two arbitrary constants, so we have to differentiate only twice. So if we differentiate this, so y dash become y double dash, and again we have to apply product rule of these two. So first e raised to x as it is, and differentiation of this is minus a constant, differentiation of sin x is cos x, plus b constant, and differentiation of cos x is minus sin x, so this become minus. Now plus this bracket as it is, and differentiation of e raised to x is e raised to x, plus differentiation of this y is y dash. Now again you can verify that if we take minus outside from this term, this entire minus, so this term and this term become plus, so we have minus, and this e raised to x and bracket, this is same as equation number 1, so we can put minus y, okay, this y double dash as it is, plus you can observe this term which we can obtain from equation number 2, this equation number 2. We can see that e raised to x in this bracket, e raised to x in this bracket, same. So we can put this value y dash minus y. Okay, so here we have y dash minus y and plus y dash as it is. Okay, so let's have a step. So this is the derivative, and we will put the value of this by taking minus outside and by equation number 2. Now by simplifying, minus y becomes minus 2y, and y dash become 2y dash. By taking this two term on the left hand side, we have this, the equation of ODE second order, okay, which is our required ordinary differential equation. And the order of this differential equation is 2 because highest derivative is 2, and degree of this differential equation, because highest order has a power 1, so degree is 1. So this is our second order first degree differential equation. Okay, similar way we have one more example. Find the differential equation, find, or we can say that obtain, or we can say that deduce. Okay, find the differential equation of the circles passing through the origin and having their center on the x-axis. So for that you have to find the equation of circle, and we all know, you all studied very well in school level that how to find the equation of circle with this data that's passing through origin. That means this is our origin and having center on x-axis. So center on x-axis and passing through origin, and as already I have learned, I will teach you in this first semester multiple integration. In that chapter already I have explained you the curves. In that we have circle also. So this is our circle, center on x-axis and passing through origin, so radius become this. So if we consider a0 as a center, so this radius is also a. And we know the equation of circle, x minus h whole square plus y minus k whole square is equal to r square. So a0 is with our h and k, and r is our radius, which is a. So we have equation is x minus a whole square plus y square is equal to a square. Now here you can see that we have only one arbitrary constant, so we will differentiate only once. Okay, not more than one, not less than one, compulsory differentiate only once. And we have to remove this or eliminate this arbitrary constant a. So we will differentiate with respect to x. We all know that the derivative of this and derivative of y square is 2y divided by dx, and derivative of e square is 0. Now we'll take this term on the right hand side. By cancel out this 2, we have this. So we can put x minus a as minus y divided by dx here in equation number 1, and making a subject from this we can put here as in the place of a in equation number 1. So by putting this 2 value in equation 1, we can eliminate arbitrary constant. Okay, simple. So from equation 1, we have this equation 1, we will put the value of this is minus y divided by dx, and value of a is x plus y divided by dx. By expanding this, taking square, expand this. By expanding this, a plus b whole square, that a square plus 2ab plus b square. By cancel out these two terms same, we have remaining is x square minus y square plus 2xy divided by dx is equal to 0, which is our required ODE. And here we differentiate only one time, so this is our first order, and the power of this is 1, so degree is also 1. So order and degree is 1, so first order first degree differential equation. Okay, similar way, before I'm just giving DIYs to you. If I have equation y is equal to ax square plus bx plus c, this is our equation. Now find or obtain or form the differential equation. So here we have three arbitrary constant a, b, c. So we will differentiate this with respect to x 3 times, and we will try to eliminate a, b, c. We have to eliminate, okay, actually. So first we will differentiate with respect to x, so dy by dx is equal to 2ax plus bx, differentiation of bx is b and differentiation of c is 0. Now again differentiate with respect to x, d square y by dx square is equal to 2a, differentiation of x is 1 and differentiation of b is 0. Again differentiate with respect to x because we have to differentiate 3 times because we have 3 arbitrary constant, and final is differentiation of 2 is 0. So this is our required ODE for this y. Okay, if you want to check that this is the correct answer, so you have to just differentiate twice and put in this equation. Same as if you want to be sure that this is correct answer, then you have to differentiate your original equation and put the value of dy by dx here, then you will get the final answer. Okay, you will get the correct answer. That okay, so uh, this is the basic concept of formation of ODE. Okay, these are the some example for formation of ODE that you have to just try. Okay, and as I told in previous semester, semester 1, if you try this DIYs regularly, you won't face, that means you will not face any trouble in examination, that you already studied very well in semester 1. Okay, and if you have any query, then you can contact me. Okay, I will solve your query. So thank you for today's lecture. Okay, keep trying, keep practicing. We will see you soon with next topic. Thank you.